Earlier this year, a paper was published in the American Journal of Science, which argued that the Louisiana State University Native American mounds are actually the oldest man-made structures thus far discovered in the Americas, and this pushed back the generally accepted date of mound building by several thousand years. I discussed this story in my weekly Ancient History News video at the time. Now, a team of archaeologists have written a response to this paper, questioning some of its central themes. So just how old are the Louisiana Campus Mounds? Let's discuss. Before we get into the mounds at the Louisiana State University specifically, let's first look at Native American earthworks in general. From around 3500 BCE and potentially as early as 5000 BCE, various cultures in the east of North America started building earthwork mounds. And this activity continued for several millennia, right up to the 16th century CE. These man-made structures were mainly concentrated around the Great Lakes and the Mississippi and Ohio river valleys, and mostly took the form of flat-topped mounds. Experts think they served as ceremonial centers for communities with complex hierarchies. More unusually, some mounds were built in the shape of creatures, such as the Serpent Mound in Ohio. These are called effigy mounds. Probably one of the most famous mound complexes is the UNESCO World Heritage Site of Cahokia in Missouri. Settled during the late woodland period around 600 CE, it was originally made up of 120 earthen mounds. Cahokia had come up in one of my news videos earlier in the year when researchers found that Monk's Mound's North Plaza, for a long time thought to have been a meeting place, would actually have been inundated with water for most of the year. I'll put a link to that video below if you didn't get a chance to watch it. The earliest mound building period is referred to as the Archaic era. Watson Break and Poverty Point are notable sites in Louisiana from this period. Watson Break dates the Middle Archaic and is made up of 11 mounds varying in height from around 1 to 7.5 meters, so that's 3 to 25 feet. It's widely thought to contain the oldest earthwork mounds in North America. Radiocarbon dates from several destroyed sites are older, but they are also debatable for various reasons. Poverty Point consists of mounds and ridges which were constructed between 1700 and 1100 BCE. It covers 402 acres and is the largest late archaic earthwork complex in North America. Timber circles also once existed at the site. Overall, there are more than 800 earthwork mounds dating to different time periods in Louisiana. The two mounds referred to as the LSU Campus Mounds are located within the grounds of the Louisiana State University campus in Baton Rouge. Mound A is just over 5 meters, so almost 17 feet in height, with a diameter of 39.6 meters, which is around 130 feet. Mound B is almost as tall but a few meters smaller in diameter. Several samples taken from the site before 2009 had provided 4 radiometric ages for the mounds. These range between 4796 and 2856 BCE and place the site in the Middle Archaic period along with 12 other Louisiana sites. Various analyses of sediment cores had also concluded that the mounds were not built in stages. Earlier this year, a paper was published in the American Journal of Science entitled "The LSU Campus Mounds, with construction beginning 11,000 years before present, are the oldest known extant man-made structures in the Americas." This paper pushed back the construction of the mounds by several thousand years. According to the new research, radiocarbon dating also revealed that the mounds had been built in 2 phases. The construction of Mound B had begun 11,000 years ago, when the climate improved following the end of the Younger Dryas, and the construction of Mound A had been started 9,500 years ago, so 1,500 years after Mound B. Both mounds were then abandoned during the climate event that happened 8,200 years ago, and which marked the boundary between the Holocene Greenlandian stage and the North Grippian stage. This hiatus lasted approximately 500 to 1,000 years before the second phase of construction began on each mound around 7,500 years ago. Construction continued until around 4,000 BCE. Samples from the deepest, therefore oldest parts of the mounds yielded layers of burned ash made up of plants and large mammal bones. The researchers concluded from these burned layers that the mounds had been used for ceremonies involving fire or had been used for cremations. Another interesting point made by the study co-author astronomer Geoffrey Clayton was that the crest of each mound aligns with the azimuth that's 8.5 degrees east of true north. 6,000 years ago, this alignment would have coincided with the rise of the star Arcturus in the night sky. Last week, a team of archaeologists led by Chip McGinsey released a response to this paper in the Society for American Archaeology's archaeological record entitled The Age and Construction of the LSU Campus Mounds, Consideration of Elwood and Colleagues, 2022. The team make it clear that they are open to earlier dates for the mounds being put forward, since new evidence which challenges long-held views has been an important facet of American archaeology in the past, such as with the Clovis first hypothesis. However, they do have some important comments to make on the work carried out by Elwood and his team. Elwood's team analysed core samples that had been extracted from the mounds by previous researchers in 2009. These cores provided evidence that Mound B was made of two different fills. One was a silt loam that covers the surrounding Pleistocene terrace, and the other was made up of lenses of a light grey silty sediment. McGimsey and team prefer to call these lenses grey bands, so as, in their words, to avoid any functional inference. This is because in their paper, Elwood and colleagues had referred to these lenses as ash beds, which, as I mentioned, implies burning took place there. Mound B was found to be more complicated, with grey sediments sandwiched between greyish and yellowish brown sediments. McGimsey and colleagues suggest that both mounds were made from the same solum. Their interpretation of the data is that Mound B is mostly composed of B horizon material, and Mound A is mostly composed of redeposited A horizon soil. The grey bands in both mounds are E horizon soils. For those of you who don't know, horizons are classifications of different soil layers. An A horizon refers to topsoil, which includes organic matter and minerals. An E horizon refers to the next layer down, which is leached of clay, minerals, and organic matter, leaving sand and silt. A B horizon is the subsoil underneath the E horizon and contains minerals that have moved down from the A or E horizons. That's putting it very simply, by the way, but I think it's enough to give this paper context. Although Elwood and colleagues concluded that Mound B was made from local soil, they suggested that the grey bands were burnt material rather than E horizon soil. Furthermore, they suggested that Mound A was made of estuarine, floodplain, or lake bottom sediments rather than soil from the immediate vicinity. McGimsey and colleagues couldn't find evidence for this latter claim in their analysis. As well as suggesting that the ash layers were in fact made up of E horizon soil, McGimsey and colleagues came to different conclusions about other evidence for fire that had been put forward in the earlier paper. This included the concentration of phytoliths, which are silica plant remains, and phosphorus, as well as magnetic anomalies. Their conclusions are that there is not enough evidence to suggest the burning of plant biomass or bone, and that other natural processes could have produced these results. In terms of dating, McGimsey and colleagues do not doubt the radiocarbon dates put forward by Elwood's team. However, the dates of the sediment that was deposited to make up the mounds is unlikely to match the date the depositions were made. Depositing earth is not a datable event in itself. It's more likely that the age of the sediments is based on natural biological activities at the site where it was taken from for use in the mounds. McGimsey and colleagues also question the two phases of construction, since their analysis didn't find the variation in colour, texture, and chemical changes that would be expected from two building periods separated by almost 1,000 years. I'm quite convinced by this latest paper on the Louisiana Campus Mounds. If the earlier paper by Elwood and colleagues does turn out to be correct, then it totally changes our understanding of the mound building cultures in North America. Such a significant revision of our understanding of the ancient past requires a lot of evidence. In this situation, I think much of the data is open to interpretation. And the questions posed and conclusions drawn by McGimsey and colleagues more than prove that the headlines earlier this year about the LSU Mounds being the oldest man-made structures in North America were a little premature. But what's also interesting, in my opinion, is that the first paper was written by geologists, including those with specific subspecialisms, whereas the second was written by a team consisting of archaeologists, a geoarchaeologist, and anthropologists. So it's refreshing to see interdisciplinary analyses and debates which arrive at different conclusions but represent incredibly detailed work by experts who have spent many years honing their craft. It will be good to see what further research takes place on these mounds and the many others in North America. I hope you enjoyed this video. Please hit the like button and click on that notification bell so you know when I publish a new episode. I'll see you next time.